Simple. Right? So, good morning, everyone. Today I give the lecture on the physical design via some open source tool in which we see the RTL GDS flow. So, before going to the physical designing, you know the how what is the meaning of the physical designing? Physical designing means any logic you think, any specification you want to design or the working format in the hardware. So that is what a physical that we can feel that IC on that properly label not specification. Then we give the some input, we get the some output. Is what a physical designing. So before going the physical designing, we try to understand some basic IC terminology. From the left figure, we see this is the complete IC diagram. There is a four basic terminology: core, pad, dia, and fourth one is the packaging. Inside the core, you see the black. Inside the core, basically the some logics and all the functionality is defined inside the core in terms of the standard cell or other logics. So after that, we use the pads. These pads basically what they do, they basically connect the input from the outside to the inside of the code to the logics. And after that, we use a one dia. In this dia, basically we fabricated complete our logic at the at dia. After that, we need a one packaging of that IC. The packaging is a very important point to designing of the IC because after the packaging we connect the pins. If you see the IC, there the aluminum, or other pins are there. So we can package that IC and use at the top of PCB designing. So the packaging basically safe uh, save your IC from the outsource of the level if there is any fluctuation in the voltage or temperature variation. So the packaging saves our IC from the outsource. So this is the four basic terminology of our ICs. So this is a basic simplified RTL to GDS flow in which I show the flow and available open source tool which can use to uh, from RTL to GDS flow. So in this flow, first you go for the synthesis. In the synthesis, we use basically a process tool. What does synthesis basically do? First, any specification you want to do, this function I want to perform. For that, first what we do, we write a one use of any language like for the software level you use C, Java or other. But for the if we want to go in the hardware level, so for that we use the SDL language like BSDL, Bangalore. So we use that language to write the behavior of our specification, and this behavioral code give to that this tool uses which basically perform the synthesis. What is the meaning of synthesis? Means the behavioral code now convert to the some gate level language. What is the gate level language? Gate level language means physically available gates like NAND, NOR, NOR, inverters, some used for the storing of the data is used to perform that behavioral logics. And this uses tool basically generate that gate level netlist. So after that, the second step is the timing analysis. So timing is a important analysis. Without doing the timing, we can't go further because if any violation is happening inside your behavioral structure or inside your behavioral logic, means if your logic is working, for the example at 1 gigahertz, we supply the clock of 1 gigahertz, but our circuit is has some violations, means the inputs and the clock is not reaching at the same point of time. So there are some violation like setup time violation, hold violations is occurs. So for that analysis, we perform the timing analysis to meet the timing criteria. So there is no violations happen inside out git level like that. For that, we use open STA. This is the open source tool. From that, we perform the timing analysis. Means how much delay required in our behavioral or RTL code. After that, we use a one tool. There are two tools basically, OpenRoad or QFlow. Today we will demonstrate QFlow, in which we perform the floor planning. Like that, you see this all. So there is a placement, there is a floor planning. How much size of that all. The same way, we will floor plan our IC. What is the width and height of our IC? After that, placement like this table is sitting here, this chairs is sitting there. Like that in our IC, there are standard cells, gates are available. So we will place each cell inside that floor plan. So after that, we perform the clock tree synthesis. Means clock tree synthesis means the clock is coming from the outside. From the PLL, basically PLL logic, we supply the clock. So this clock should be reached to the all cell and cell at the same time. For that, we use a clock tree synthesis. For that, we use a S tree. You know the S tree? Like this S is used at the clock or corner. We use a different cells and supply the clock. So at the same time, clock is reached to the all four head of the X. So like that, we perform the clock tree synthesis. After that, routing. Routing is how the power supply, ground supply, and the signal is routed to the outer cell from the outer most of the IC. For that, we perform the routing. After that, after the routing, we get a one called a GDS file. GDS is nothing. It's called a geometric data stream. Means it's you define the geometry of your IC and their layout inside that IC. That is basically called the GDS. That GDS is supply to the technology file or any vendor who will fabricate your IC. So this is some list of tools which is available, open source tools. First is the process, which will perform the synthesis of your ideal design, and second is ABS tool, which is basically used for the mapping your netlist to the available standard cell, which is provided by the technology libraries. You know the tech library, like you so see directly processor. You have a mobile phone. How many how the technology library you use to design a processor, like you see that 7 nanometer technology you use to design your processor. So that 7 nanometer, 22 nanometer, 40 nanometer, 65, 44, 180, 130. That is basically a technology library which basically used to design your IC. So currently the industry is basically working toward to the 3 nanometers. Many currently iPhone 15 basically use the 5 nanometer processing. So after the mapping of netlist, we perform the static timing analysis of our RTL. All the timing should be matched. For that, we use the OpenSCA tools. After that, we use the OpenRoad, or in place of OpenRoad, we use QFlow. to perform the floor planning, placement, clock tree synthesis, optimization, and routing. And after that, we use a one tool Triton route for the detailed routing of the metals and all the things inside the your IC. After that, there is one tool Magic VLSI, which is basically used to design your layout or try to see the visualization of GDS file to the Magic tools. And there is the NG Spice. This basically this tool to perform the spice triangulation. So that tools it has some spice netlist. So from that tool we provide some input plot and see the corresponding output through that NG Spice tool. After that, there's the SPEF extractor tool. What that tool? If you know that, uh, this tool basically generate the parasitic like capacitance, resistance, value, which uh, included in your matches. They extracted that value, and that value will be used during the timing analysis because capacitor needs some time for the charge and discharge. So from including that SPF file, we get the exact timing analysis. How much time we require, how much delay we require during the process. So yes, first I completed. Then you note down your doubt. After time we clear your doubt. So from the we know that RTL to GDS. First we know the what is the RTL. RTL is a it stands in the name of register transfer label. RTL is basically a digital circuit storage in which we use a hardware description language which basically contain the combination logic, registers, modules like analog micro, SM micro, NANDs, extra is included into the RTL. So this is the one of our example of RTL in Verilog. So what in the Verilog? First we define the module name like a helper delay at 2. Inside of the bracket we define the input, what is the input and what is the output of particular modules. After that we use a one register and a stage. This register basically used to store our intermediate data or final output data. After that, inside of that always block, we define the behavior, what the logic we want to do in the combination logic formats. So this is the one example of our RTL in Verilog. So today we have discussed first uses, which is open synthesis suites tool. So uses basically perform the behavioral synthesis, RTL synthesis, and the logic synthesis. So in the behavioral level, they just take the RTL code like Verilog code, simulate that, and see the behavior. What is the behavior if we apply some input? What is the behavior? Means the behavior means what is the output of that RTL. After that, they transfer that complete behavioral code into the RTL. RTL means they now make one netlist or one code in which they use a adder, multiplexer, and demultiplexer to implement that behavior. And during this logic synthesis, what they do, they available in that technology library. They use that such like NOR gate, NAND gate, inverter, XOR gate, and D flip flop or OA gates, AO gates are used to develop the logic synthesis. After that, they basically generate a gate level matrix. And these different gates are used to design your behavioral codes. So this is the just what is the input and what is the output of uses, which is basically a logic synthesis tool. So in this tool, we first give the .lib file. .lib file is basically provided by the your technology libraries. Like for there's some industry called TSMC, UMC, Global Foundry, Samsung. They provide the some industrial library. For the open source tool, there is some open access libraries also available like 945 nanometer and one Silvaco 15 nanometers. And currently I working on one SM 7 nanometer FinFET technology. They provide your technology library for the your behavioral analysis. So second one we give to the RTL code, right? In the RTL code we give to the logic synthesis. After that we can give the some timing constraint, and fourth one we use the flow state. In this flow state what we do, because every tools work on the command lines. Okay? Work according to that command. So in the flow script, all the command is written. Either you will write one by one command, or either we run complete script to generate the gate level netlist. After that, process also generate the static report, like how many instances are used by your behavior, how much area consumed by your behavior, codes. So this is the set command which we use to run the process tool. Dot log file. After that, we run command. One we just write the one TCL script. Just process. Okay. So just command. For that, if you don't have a Linux version, so what you can do, you just install the this is the virtual box. Inside the virtual box, install Ubuntu 22, which I install other open access tools, in which we done some analysis. Hey, open access tools, all the VLSI tools run in to the Linux environment. No, no into Windows environment. For the Windows environment, either we go to the virtual box, or there's a one other thing through which we can run, like a Docker, which we can also try to run. Because every VLSI tool work in the Linux environment, they need some command. So I already make some. So first we open the terminal inside that folder. Now for the running of Yosys tool, what we do, we just type Yosys. That command we already written into the PPT, and make .log file. That log file we make because if something is missing during the running and after the complete execution, if we want to see some what happened if we run the some command, what has happened. So all the things is stored in this log file. So just type the our process tool is now the process is open synthesis tool. This now this tool is done. So just, and you can also see this log file is generated here. So I write some scripting file. This is the scripting file I have already written, in which all the command I have written there. So first what we do, first we read the library or tech library. For that we just take the this command, and the library I stored here this 9845 nanometer critical condition library file. So I just take that command from that script, because here I use user command and run. Either you can run complete script, but individually running we see the after the command what has happened. So individually I running that command. First is this read liberty file. Now I just take the name of that library, because we are running your research tool inside that folder. And library is also there, so we just take the name and put there. No path needed because terminal is running at that folder. They just take the library file from that. Now executing Liberty front end, and this we can see they imported 132 port cell. This standard cell library has a 132 134 different standard cell is available inside that library. So what the next? Now we need the our RTL code like .b file. Read the Verilog file. So for that we just take that command read underscore Verilog. So this all the command I have also included in our PPT. You can refer from there. Now, now we put the name of our .v file. So here I use two Verilog files. One is a counter and second is map9v3.v file. So we go for the counter. This is a simple counter. Just count the value from 0 to 8 or 0 to 7. Just take the name, copy the name, counter DB, and put the enter. Successfully read or dialog code. If there is any syntax error, they define that key in your code, there is an error. So they successfully finished Verilog front end design. After that, reading the Verilog, we first check the hierarchy of our Verilog codes. During the writing, this counter is small code, but if we write in the bigger code, for that we use some smaller code inside that code. But so for that we check the hierarchy check top. The top model should be a counter or should be any your RTL code's name. So for that, because our code is out counter, so we just check the hierarchy. Our top module should be a counter. We just take that code. Oh. Because there is a one mistake, no such command is there. Because there is some mistake in hierarchy, the spelling. HIERARCHY. Just refer that. HIERCHY. CHY. Now, this command is running correctly. They set your top module counter. So after that, what we do, we perform some convert this counter to the use the one command as this cross command. Just take this cross command and there enter. Now our behavioral code is right into the RTL code, like use a mux, the rows as rows mux is used. For that, our one command is there. So This is the basic key how now our RTL is developed by the add Maksar that is used to implement after the running the cross command. This at least we will get. In this no technology gates are used. Okay. इसमें आप देख रहे हैं कि add bugs use RTL is generated. इसमें कोई भी टेक्नोलॉजी का कुछ भी नहीं है. Just the user normal bugs adds to default to to generate through this user tool. Slide में बताया था. हाँ ये RTL synthesis कर रहा है. .b फाइल अभी के लिए तो एटलीस्ट बनेगी. Last in the last. हाँ लॉजिक सिंथेसिस अभी वो कमांड हमने चलाई नहीं है. ये सिंपल RTL सिंथेसिस की है उसने. अभी RTL बना है यूजिंग मक्स. इसमें अभी कोई भी टेक्नोलॉजी को हमने कोड किया नहीं, मैपिंग की नहीं, लाइब्रेरी के गेट्स को मैपिंग की नहीं. So this command basically used to see the intermediate are waiver. In the PPT we can also see that. ये इस तरीके का मतलब चेक के बाद भी after the check we can see that and after the process we can see that result. So in this way we can see. Now we can go to the further step. Like now we perform some optimization in our RTL. So just take command opt. There is nothing left to do. So they perform some optimizations. If there is any mistakes or anything is wrong, they perform the optimization and done. After that, if your code has any FSM code, like final state machine is there any code, for that we use the command of analyze the FSM and make that FSM. So just type the command FSM. So by this command, what we do, if any FSM is there, so they basically map that FSM by the basic logic gates. So after the FSM, we again perform some optimization. For that, we take the bulk after. Now the next step, if there is any memory like SRAM or registers, for that we write one command like map. You want to map the memory. Any memory. So now this memory map is passed. Convert memory cell to the logic and flip flop. Now the any register that is used inside your RTL that is mapped to the flip flops. So after that we can also see how our netlist is showing. For that we again put that command show stretch. So there is a previous step is now step is similar because our code marks that already flip flop is there. So there is no registers present in the counter, so no mapping of the memory, no FSM is there, so nothing is there. If your code has FSM, they define their FSM by the different logics. So after that we perform some optimization. The optimization basically performed during the if you have a larger number of code. For that optimization is efficient to implementation of your gate level netlist. But counter is smaller, so there is nothing happens in the optimization. Like that, if there is a many your codes, they use a different logic gates to design your RTI, but some of gates is not required. So during the optimization, they just remove that gates and optimize your RTI. Optimize in terms of your area and optimize in terms of your timing. its delays, if you reduce one gate, delay is drastically reduced. For that, there are some optimization. So now after the optimization is performed, now we make map the technology one command tech map. Now we try to map our technology into the RTL. For that we uh, put the command tech map TCH For the now we go toward to the logic system. Yes. So for that now this net list is generated. Now again we perform the some optimization. This is just a step. We just follow. In the optimization, you can also see execute RMDPP, pass remove D flip flop with constant value. You can also see that what the optimization is performed. You see that in the log files also. So now after the optimization, what we do, we just map the D flip flop which available into the library and map to the our RTL codes. So for that we use that command paste add and name of our technology because we use here NAND gate 45 nanometer typical library. So just took that command. वो deep flip flop is basic, but now we map the deep flip flop or available inside the technology file. So that to technology file में deep flip flop है because now deep flip flop liberty. We take the deep flip flop from the library. Library से हम अब उसको मैप कर रहे हैं. पहले वाला जो था तो लाइब्रेरी का नहीं लाइब्रेरी वो स्टैंडर्ड नॉर्मल वो जैसे कि आप विभागों में करते हो वो लेता है ना फ्लिप फ्लॉप ले लेता वो फ्लिप फ्लॉप था. They use a different D flip flop like here you can see the finite D flip flop cell mapping D flip flop x1 this is a D flip flop is used in your gate level netlist. So जितने भी working gates वगैरह हैं AND gate उनको भी RTL code हाँ AND gate NOR gate that is available हाँ मैप करना पड़ेगा in the this after the RTL code में उनको भी मैप करना पड़ेगा that available into the cell we go for that. Look, the fourth. After that, we again perform some optimization of command. Now we perform for that map logic to the available gates. For that, we use that ABS liberty command. ABC is another tool which map the technology file logic into the our netlist. Paste and just take the library name. Now this all logic gates from that we can see and 3x1 cell 1 AOI 2 cells are used inverter x1 1 cell are used to design your RTL like that NOR, OAI, XNOR are used and 9 number of internal signals, input signal is 5 and output signal is 3 are there in your gate level netlist. So after that state, now we use one command as a flatten command. So after the flatten command, now we perform the undefined. If there is any undefined logics or undefined input block, we make them to 0. Means clean that D flip flop. So for that we perform the. In this counter there is no undefined, but if you use a larger number of value of code, bigger. So in in that case, there is a very possible of undefined logic gates are there. For that, we put that command. Which are not available in library. Many used from the library, but it is not properly used in your RTL course. That is means no benefits of using of that logic or deep law. For that, we will make them zero. Unnecessary, they consume the power. Unnecessary, they increase the area. Unnecessary, they increase the delay of your RTL course. After that, if there is any unused cell, unused wire is there in your get level net list, so just need to make the command clean the unused wire and unused cell. For that, we use the command clean hyphen purge. So just from that, we can see after running, they remove because there is no unused cell, but they remove erase unused wire. Just present inside your get level net list. ABC results are इसके आगे तो ये आ रहा है इन्वर्टर और हाँ this is this say that कि one number of one and get used one AO gets one inverter one NOR one NOR three one OAI one XNOR two हाँ gate level में this is the count of your standard cell used to design your RTL code. Yeah. This command basically we use to put the some IO pad, like input output pad, which is basically provide from the buffer to the input signal of your RTL. For that, use a IO pad mapping. This command we use just for the mapping of IO pad or buffer to the internal of your RTL. So after that, we again perform the some optimization of again we use some clean command to use shell and while. Now for that stat liability, basically print the statics like area or number of cells are used to implement your article. For that, we use that command stat liberty. And the library. This is the statics, similar statics like how many wires, memory bits, number of cells, and their corresponding area is required for the development of the chip of the counter, like 22.078 micrometers square is needed to design a counter. But this is not an exact area of chip. In the chip, the like interconnect area, other wiring area should be included. So approximately the area is approximately 90% is exactly given by this process tool, but not exactly is required to design your chip. So this analysis basically for during your particular value of analysis during the research, how many areas you need to design a particular structure, particular architecture, particular specification if you want and design it to the RTL. For that, we can analyze using the technology library. We need this amount of area for the just for the comparison purpose. The previous one need this amount of area, or structure need this amount of area, and we want improve in terms of area for the comparison purpose. We do the analysis. So after that, we this is the final stage in which we write the gate level address of our counter. So for that we take the right verilog name as counter final dot p. Run it. Now our final gate level address is generated and stored here. This one. This is the netlist. All the gates they are used to design this. So after we can also see the netlist by that same command. So नहीं in this ना symmetric form है ना I to that same command so hyphen stretch yes. This is the symmetric. You can see the symmetric now. And this is the gate level netlist. For this gate level netlist we use for the further the open SDK. For the further designing from the RTL to GDS. Not that B file we can't use in the open SDK. We need a netlist for that. So this netlist we generate from the uses or any RTL to GDS flow need uses or other tools they can use for the synthesis purpose. If you go for the license to like cadence, in the cadence they do the GDS for the synthesis tool to converting the dialog file RTL code to the gate level netlist. That gate level netlist further used by the other tools to generate a GDS. They use Novus tool. Inside the Novus they do the tempers for the timing analysis. But this is the open access tool. This is available for the free. So if you don't have a license version, you can use that tool for the your research purpose, for your analysis purpose. Like if you design something, if you want to analyze at a particular node, so we can analyze through this open access tool and also do some research like this. This is a reliable because this is many people are using Yosis open access tool and many industries are also using to fabricate the IC using that open access tool. So I am working in the industry, I am also using that tool. Because some startup company don't have so much fund. So for that, initially for the research purpose, they go for the open access tool to analyze their thoughts. Initially say they are thinking the right way, means they are thinking that the power comes into the this amount of range, area come into this amount of range. For that purpose analysis, for the research purpose, we can go for that. And we can also make fabrication by using that open access tool. Many ICs are fabricated using that open access tool. Like IT Indore currently fabricated two ICs using that open access tools, using Sky 130 nanometer libraries. Because library is also fabricatable because 948 is not fabricable library, but Sky 130 is provided by the Google. This is that library you can fabricate. For that, there is one company like eFabless, you know, they basically use that open access tool to design the IC using Sky 130 nanometer library. So this is a gate level netlist. In the timing analysis, you can see that at what frequency your structure is working properly. What is the maximum frequency that your structure is working properly? In this, they just analyze the critical path, means first critical path from the input to the many paths to the output. How much delay they require for that the first path delay. From that, they just calculate the frequency. At this frequency, your design is working perfectly without any worry. No, for that we need another tool like OpenSCA. Yes. For that we need this just a synthesis tool. It's just a generator gate level netlist using any technology library. This, if you want to see this technology library, this is the technology library can get typically and operate at the 25 degree and the supply voltage of that technology. You can see by opening that library file. You can also see how many cells are up there. This is basically a CMOS technology library, and from there you see the different sign outs and different logic gates, which like and to every cell is defined, and their corresponding power, area, everything is defined inside that tech library. So this is basically a tech library. So if you want to download, you can easily download the users tool from that GitHub link. They have also one website from that you can download the users tool. I said that's like with you. You can take. But installation, apart from the installation, in the Linux, they need some extra packages. You should install that packages also to the your Linux environment. Initially, you install the Ubuntu. They don't have so much packages. So आपको कई packages install करने पड़ेंगे to run that tool perfectly. ये कोड्स tools वगैरह हाँ to open source yeah you get many resources. You can there is one PhD to run Udemy from Udemy to take the code of PhD from that they teach different codes because the process is very simple code. If you follow this same command, do different technology, different value of power, use same methodology. So today you learn uses. Any doubt? Uses. I just give you the command, just take that command. Just you understand the technology library file, you take, you write a value of path, take the folder and everything should be inside the folder. Like this कि जो जो हमें स्क्रिप्टिंग फाइल प्रोवाइड कराएंगे इसमें we make this path. If you are running in the same folder, you don't need that path. Just open terminal same folder, and in the same folder, if you have a technology library, you can just put the library of name. They can run. No need to provide complete path. If the library is stored in another place, then we need to that path. In the same where we run the terminal, at that same terminal, you have not stored that library, then we need the path of that technology. From the UP, so you can learn uses tools and you can also one professor of IT Roki, they are also giving the lecture on uses. Dr. Vishnu Das. You can also look up from the NPTEL video lecture from that. You can, they are easily available in YouTube. They are giving the same demonstration of the uses tool to run. If you after going there, if you have any doubt, you can refer that YouTube lectures. So, all the code RTL code which you write in library is available free of cost. You can download that. Make one single folder based on the files in that folder. Either you can put all the library file any folder or that if you try to run, you just give the path for that library. I think write the command, the path you giving the name of your library. You not need to store the technology library into the same folder. Just give the path to the library. So NAND, there's NAND libraries, NAND 45 is available free of cost. 45 nanometers. So these are the resources. So the second important aspect of RTL to GDS flow the timing analysis. For the timing analysis, we can refer the open STA tool. Similarly, the static timing analyzer take the library file, the net list, the get level net list which generated from the your your sys tool or any other synthesis tool. Some timing constraint like your clock, what is the input delay at your input, that output delay, and same as a flow script file, like the TCL scripting file. In this, all the command is written. After that, we also provide the one parasitic SPL file into the timing analyzer to exactly analyzing the timing reports. Output is timing report, and one is the SDF file, standard delay format file of your RTL codes. So this does the command. So command we describe here. We read liberty means just read your library file, read your Verilog file like example1.b file. Link design top means whatever is in your deal code, make it as a top module. Means link design top the name of your top module. If your module name is here the counter, so you put there in place of top you make counter. Read SDF file. So there is a one display format is available. We can read that SDF file. Now we will create clock, name, clock, period, 10 is 10 nanosecond. Period of clock we use, and this 3 clock is used in our example1.b file. So we supply the clock to the all 3 clocks, and for that we use the 2 input IN1 and IN2, and we put the 0 delay input delay at both the output. For the last command, we just check report underscore checks, means we want to check how many timing or delays happen inside our valid output. In place of that, we go just go there. Now I open the standard cell. So I write the different scripting file. So first I give the this. So in this step, first we need to create the library. First, what we do, we run, close that terminal, and here for the running of OpenST, there is one command STA. Enter. OpenST is running. So first we read the our library, read library, same name gateways, run. So the one library successfully read that library. If any error, they don't show one there. After that, we read our Verilog code example1.b file. We put there. Again, successfully read. You can also see that this example1.b file. This is the gate level access. It is already generated. Is the gate level access, not that Verilog file which you use to define the gate level. And they use the different logic gates of your standard cell library. Thus, they use the inputs like IN1, IN2, clock 1, clock 2, clock 3, and one output is used. So now we will link your design top. Why we make this top? Because if we see there, the name of model is top. Therefore, we make them the command name is top. So again, paste link design. Now linking our module to the STA. For that, first I try to run our design without using of any parasitic like this. That I don't use any capacitor and resistance. Just I wanted to check the timing. For that, we first create clock. Set input delay. Now we go for the report check. They give us some timing reports. From that we can see that one thing slack. If slack is negative, then we can think that there is any violation. If like that, if the period here I mentioned 7. If we write below the 7, there may be chance of that कि आपका circuit काम ना करे. If slack negative में आएगा, then there is a violation. But this is there we can say that slack is coming at 6.43. Means slack is basically data arrival time minus data required time minus data arrival time is called as a slack. Means data at what time data is coming and at what time data is required. यानी डेटा बहुत फास्टली आ रहा है, टाइम बहुत ज्यादा है कि डेटा पहले ही आ गया है लेकिन उसे रिक्वायरमेंट बहुत बाद में है. अगर रिक्वायरमेंट इधर है, डेटा बाद में आ रहा है, दैट्स अ वायलेशन. उसे डेटा मिल ही नहीं रहा और उसे उस टाइम पे चाहिए, देन वायलेशन आ रहा है. तो इसमें मैंने क्या किया, इसमें कोई भी कैपेसिटेंस यूज नहीं किया है. नाउ वी रीड द SPF file like the parasitic capacitance which inside your netlist, that we will read it. For that we one.dsp file, just read that SPF file to include the resistance and capacitance. Then again perform the report check. Now what is the report? You can see that slack is minus. There is a violation occur. Data arrival time is required 7.9, but data is reaching at 6.43. So what we can do now? Again we come here. We just change the timing. 7 nanometer पे काम नहीं करेगा हमारा सर्किट. So we make at 10 nanoseconds. Again we will create a clock. Both the code we run. Again we report. Now the slack is positive. Like the data required time is data required time is 9.3 and data arrival time is only 7.92. So from if we want to analyze this, just open that. This is basically giving the data arrival time, and this basically giving the data required time. Data required time is defined by the clock. 10 nanosecond clock we provide. There is some setup time delay like 0.57 setup is required to set up your clock. So 9.43 time of the clock is available to perform your any logic. And there's a delay. If we perform the delay analysis, then only 7.29 second is required to apply the clock to get the output. So from that we can think that can you from that timing analysis can you exactly calculate it at what frequency this counter is working perfectly? Maximum frequency by using only this timing analysis. You can see the timing. You can calculate from that. 1 gigahertz is very fast, 1 nanosecond. There is a 10 nanosecond. 100 megahertz. हाँ 100 मेगाहर्ट्ज नहीं, कम पे काम करेगा, नहीं ज़्यादा पे काम करेगा. कैसे कैलकुलेट कर सकते हो? डेटा अराइवल टाइम इज रिक्वायर्ड बाय 7.92. This is required, but there is one another like 0.57 is needed for the second. So if we add this 7.92 plus 0.57, from that you get the exact timing like that. So from 8.4 picosecond you can calculate the frequency. This amount of frequency your circuit is working, maximum frequency. हाँ setup time. नहीं, data arrival is required for the period of clock. Period of clock, 1 by time of period giving by the frequency of your time. There is one command from the. There is another command. If you wanted to check the capacitance value at your different gate, how much capacitance is there. So for that we put that command. So they also included the capacitance value like this. In this relay there is no capacitance, but if you want to check the capacitance value at this D flip flop Ekman buffer and this amount of capacitance are present in this all the standard cell. According to that, our delays means our data arrival time is increased, and our slack now is only 1.52. You can also see there the slack is 6.43 without capacitance, and with the capacitance our slack is only 1.52. So during the time analysis हमें ध्यान रखना होता है कि capacitance should be there, वरना वो time analysis is not correct. आपकी कैपेसिटेंस और रेजिस्टेंस जैसे कि आप नॉर्मल पढ़ा होगा पोस्ट लेआउट एंड प्री लेआउट सेपरेशंस दोनों नहीं अगर एमटेक और कोई बात नहीं. प्री लेआउट सेपरेशन होता है जिसमें हम कैपेसिटेंस वगैरह कुछ नहीं लगाते, सर्किट बनाते हैं, इनपुट देते हैं, आउटपुट निकाल देते हैं. इसमें कैपेसिटेंस कुछ नहीं होता, तो आप क्लॉक दोगे फास्टली चेंज होगा क्लॉक जो भी आउटपुट होगा. बट जब वो कैपेसिटेंस अगर इंक्लूड करोगे तो इनपुट दोगे, लेकिन उसका जो आउटपुट होगा कैपेसिटेंस पे डिपेंड करेगा चार्जिंग डिस्चार्जिंग पे, तो वो डिले ऐड हो जाता है. तो वही जब आप किसी भी सर्किट का लेआउट करते हो तो वो रेजिस्टेंस एंड कैपेसिटेंस आर इंक्लूडेड, तो वो डिले आएगा. तो एग्जैक्टली विदाउट द कैपेसिटेंस इंक्लूड करके आप जो टाइमिंग एनालिसिस दोगे दैट इज करेक्ट. सो टाइमिंग उसी स्पीड से कैपेसिटेंस बना होता है कि रेजिस्टेंस भी होता है, कैपेसिटेंस वैल्यू भी होती है. हां, तो चीजें आपका डिले करता है, यानी डिले बढ़ जाता है. मतलब आप देख सकते हो कि उसमें जो डेटा अराइवल टाइम ओनली रिक्वायर्ड 0.4, इसमें डेटा अराइवल टाइम रिक्वायर्ड इज 7.9. कैपेसिटेंस डेटा उसके कारण
तो एक फाइल जो उसमें टेक्स्ट वाली इंक्लूड करिए ना,
हाँ उसकी वजह से उसके लिए अलग टूल होता है उसको जनरेट करने के लिए. वो RTL की GDS फ्लो में जाते हो कोई भी टूल, तो वो फाइल को ऑटोमेटिकली जनरेट करता है, उसके पास टूल्स होते हैं. अभी थर्ड वन में मैं क्यू फ्लो बताऊंगा, उसमें दे जनरेट दैट STL फाइल and perform the pre layout and post layout as both. So after that, after timing आ गया, area you can get from the usage. अब थर्ड क्या रहा, पावर, कि आपका सर्किट पावर कितनी लेगा. तीन मेन पॉइंट होते हैं आपके कोई स्ट्रक्चर के, कि एरिया कितना लेगा, टाइमिंग क्या है उसकी, किस फ्रीक्वेंसी पे काम करेगा, और फोर्थ वन इज पावर. तीन पे आपकी चिप डिजाइनिंग और वो कुछ भी स्ट्रक्चर डिफाइन करता है. तीन परफॉर्मेंस पैरामीटर्स होते हैं, इन सबको आपको मैनेज करना पड़ता है कि पावर ज्यादा ना ले, जिससे कि लार्जर बैटरी छोटी बैटरी साइज को ज्यादा करने के लिए चल पाए. जैसे कि आप मोबाइल पहले मोबाइल से घंटे चलता था, अब मोबाइल लगभग 24 घंटे से चल जाता है। तो आपकी डिजाइनिंग के ऊपर है कि आपका डिजाइनिंग कितना एनर्जी एफिशिएंट है, कितना कम एनर्जी पे वो काम करता है। So for that, we make one other. Now this power analysis are done by using Sky 130, which is a fabricatable library using TT transistor coder. For that, we use another diagonal code GCD code. This is a bigger code. So for that, I just again read that library. So in this terminal, previous library is there. So again, we need to read newer libraries, read that library, and because I'm using different Verilog codes for that, so again we read the Verilog codes for that, and after that, make the link design GCD. One, I think there's one warning. One ground is not found. Okay. Now we read the SDC file. You know the SDC file? SDC basically calls synopsis design constraint file. In this constraint file, what we define, they define similar define clock, input output delay. Same thing we define here in the SDS file. The previous we give the SDC some clocks, input delay in the terminal, but here we just read the SDC file. And right here, one mistake. They said that read SDC cannot open because I think I example one example one. Gate level access I have already called. हाँ हाँ, ये किए ना मैंने, देखो सेकंड कमांड। First we read the library. Second we read the net list. This is the net list. दूसरा है, not the previous one. This is a different one. The previous one की मेरे that don't have HTC file for that. After that we perform the set propagate clock. Again we need to read the HDF file. For input activities we both we run parallelly. Okay. the final command report underscore power to check the report of your line RTL code. So here we get the report of your RTL code in terms of internal power, switching power, and leakage power. So from that we can calculate the total power amount 1.19 micro milliwatt amount of power is consumed by your consumed in your RTL code in Sky 130 nanometer library. Because this is a 130 nanometer and GCD code is very bigger code. So due to this, they consume this amount of power. If you go to the lower technology library, the power consumption come into the like in microwatt. If you go for the 22 or 14, 15, the power consumption is coming to the microwatt range. So from that we can take the power, how much power your circuit is consuming. By these three parameters, you can compare your circuit with the all other circuits, or you design with the all other design. What is the if your structure is improved in terms of power, you can that this amount of power is lesser in our design when compared to the other design which is available. So in this, we can also see that our delay is lower, like our frequency is higher in our design. Our in terms of area, we can also tell that our circuit is taking lower area or maybe larger area, depending upon your designing, how you write your behavior goals. So this is the basic open SCA through which you perform the timing and power analysis. Huh? GCD as GCD कंटेंट फाइल होती है सेम जो मैंने क्लॉक डिफाइन की थी ना ये मैंने इस एसडीसी फाइल के अंदर लिखी है यू कैन रिफर दैट इधर होगी ये एसडीसी फाइल ये रही वही है ना क्लॉक को डिफाइन करता है पीरियड डिफाइन करना पड़ता है क्लॉक डिफाइन करना पड़ता है इनपुट आउटपुट ग्रुप्स डिफाइन करना पड़ता है जो प्रीवियस में क्लॉक डिफाइन की थी पीरियड डिफाइन किया था सिर्फ एलटीसी फाइल है या क्या एक फाइल में ही लिख देते हैं सारे बेसिकली इसका नाम होता है सिनॉप्सिस डिजाइन कंसेप्ट एफपीए पे काम अभी हमने कर दिए उसमें आप ये एसडीसी फाइल बनाओगे उसमें भी सेम एक फॉर्मेट आएगा क्लॉक ये क्लॉक गेट पोर्ट कोई एसडीसी फाइल वहां भी है बेसिकली कंसेप्ट क्या कहलाती है और टाइमिंग के लिए और जीसीडी आप जीसीडी कुछ है जीसीडी एक ब्लॉक है वेरिएबल कोड है नाम है जीसीडी का एक कोड है तो टीसी के अंदर वेरिएबल कोड है और उसकी गेट लेवल नेटलिस्ट दी होगी ये रहा जीसीडी ये तो वेव फॉर्म आ गया इसमें ये जीसीडी बहुत बड़ा कोड है बहुत सारे बाइट्स और बहुत सारे गेट्स इसमें स्काई 130 के यूज किए हैं फिगर कोड है कहां पे बहुत बड़ा है किसका बीटेक में बता दीजिए कि तुम्हें फर्स्ट यू ट्राई टू अंडरस्टैंड द वीएसआई का थोड़ा और देखना पड़ेगा आईसी के बारे में थोड़ा पढ़ना पड़ेगा कि क्या होती है आईसी फिर कुछ स्ट्रक्चर जैसे कि तुम अभी तो डिजिटल इलेक्ट्रॉनिक्स पढ़ी क्या क्या पढ़ा डिजिटल इलेक्ट्रॉनिक्स लॉजिक गेट्स पढ़े ना कॉम्बिनेशन लॉजिक गेट्स पढ़े हैं अगर कोई एक सिंगल गेट एंडी बनाना है तो हाउ टू डू डिजाइन अवेयर ऑफ दैट और लैब कौन सी ईयर में सेकंड फोर्थ ईयर में आओगे तब प्रोजेक्ट करोगे इलेक्ट्रॉनिक्स में होगा तब कुछ पीसीबी डिजाइन कुछ करोगे आईसी का यूज करके कुछ प्रोजेक्ट बनाना पड़ता है ना पहले ईयर में तो आईसी यूज करोगे मार्केट से लाओगे रजिस्टर लाओगे और फिर कुछ सर्किट बनाओगे वो अलग है और इसमें क्या करते हैं तो सैंडविच भी जो भी सर्किट आप बना सकते हो कई टूल्स अवेलेबल हैं इम्बेडेड में जाओ तो इम्बेडेड का तो अलग है आप असेंबली लैंग्वेज का यूज करके माइक्रो कंट्रोलर प्रोग्राम करते हो फंक्शन को कंसोलिडेट करने के लिए मशीन को कोई भी मोटर है पर्टिकुलर किसी को रोटेट करने के लिए कोई भी डिसीजन लेने के लिए जैसे कि स्मार्ट वॉच के लिए इनको आरसी डिसीजन देती है तो पहले धीरे फाइनल ये जाओगे तब तुम्हें धीरे धीरे साइकिल को स्टार्ट करोगे ये सब्जेक्ट होता है फिर सेकंड ईयर में हो तो बेसिकली समझ लो कि इसमें वही है जो तुम नैनो पढ़ रहे हो सीधा फिजिकली टेक्नोलॉजी फाइल देती है इसको स्टैंडर्ड सेल कहते हैं उन्हीं का यूज करके हर एक आरटीएल टू जीडीएस जाते हैं कोई भी सर्किट नैंड और नॉर मार्क्स में बराबर यूनिवर्सल होते हैं इससे आप कुछ भी डिजाइन कर सकते हो कुछ भी फंक्शनलिटी होगी हमें ये चाहिए उससे ट्रुथ टेबल से डिजाइन करोगे ट्रुथ टेबल से आपका एक सर्किट बनता है जो गेट्स के थ्रू नेट गेट और नॉन गेट वही नेट गेट्स चाहिए तो बनाते हैं यहाँ हम लोग क्या करते हैं उसको टूल्स के थ्रू हम डिजिटली रिप्रेजेंटेशन की तरफ जा रहे हैं डिजिटली उसका आईसी डेवलपमेंट ये अगर इलेक्ट्रॉनिक्स इंडस्ट्री में सर्वाइव करना है तो इसका हमें नॉलेज है एक्सपर्टीज है तो ज़्यादा है क्योंकि आज से कुछ साल यानी देखोगे लगभग बीएसआई इंडस्ट्री में जॉब की बहुत रिक्वायरमेंट है ये नहीं है सभी लोग बीएसआई इंडस्ट्री में बहुत सारा इन्वेस्टमेंट आ रहा है सो is there two Third is a Q flow. This is a complete flow of from the RTL to GDS, fully automatic. You can't do anything. Just write one command, take your RTL, give the technology file, the tool automatically perform your timing analysis, synthesis analysis, power analysis, floor planning, placement, routing, all the things is done by that Q flow tools. And finally, they give you a one GDS file. In terms of layout, you can use this to the company. They can fabricate your item. So this Q flow initially used for the only research purpose, not for the fabrication purpose. You do some research. So just is the simple. I just open here this folder Q flow. Open terminal, just write command Q flow in GUI mode. GUI mode means graphic user interface mode में open कर रहे हैं Q flow को put enter. Q flow is open. देखो left side देखोगे checklist all the जो देखो बनाई थी all the flows in there ना. First preparation means preparation is very important. Second synthesis, third placement. After placement, we perform the static timing analysis. Then routing, and after the post routing, we perform the post route STA static timing analysis. Then migration, then perform the DRC analysis. Means any during the layout, if इसमें क्या डिजाइन क्या होगा? कि particular कुछ design rules हैं. के अकॉर्डिंग ही आना है अगर वो आपके एरर आती है तो आपका लेआउट नॉट वर्किंग इफेक्टिवली सो वी परफॉर्म द डीआरटी एलबीएस मींस द लेआउट वर्सेस सिमेट्रिक व्हाट इज योर सिमेट्रिक व्हाट इज योर लेआउट दे मैच परफेक्टली टू ईच अदर एंड आफ्टर दैट वी जनरेट द जीडीएस फाइल ग्राफिक डिजाइन स्ट्रीम पैकेज ज्योमेट्रिक डिजाइन स्ट्रीम This is basically giving the layout of your IC. And that we will give to the for the fabrication purpose. So the steps of cube flow is very easy. We just open the cube flow. Here we select our while lock like this. Open. So while lock module is counter. There's a in this tool there is a 1, 2, 3, 4, 5 different technology library like OSU 035 means 350 nanometer. OSU 018 means 180 nanometer. OSU 50 and GSL 45 nanometer are used. So initially today I demonstrate with the OSUS 035 this technology. So after that, what we do, we just uh, put the run. So from that preparation, you say that symbol is okay. The green means this style is running perfectly. So in the second step, so in this we perform the synthesis. So we click here means after the synthesis we stop. If there's an error or anything happen, so you can also see there this log file here inside that what is happening inside that tool. So I just perform the run. So the synthesis is performed correctly. So the symbol okay. So from the left side in the setting, we see there some points is there. Initially density, aspect ratio, create power stripe, strip pitch, and arrange pitch. Intensity density means होता है कि आप initially जो आपने slide first figure देखा, कोड देखी थी, वो basically उसमें अगर 1 लिखा है, density means होता है कि all the logic rules, all the logic steps of instruction, it's filled by the all complete codes. In this smaller design, we don't need the metal wires, small metal wires, so we can give this at a one. But if we have a larger IC, so for that we don't make as a one. We make them 70%, 80%, and 20% we use for the routing purpose, like the routing of metals, like power strip, ground, and other systems for the routing. We take that as 20% density for the routing purpose. And aspect ratio, if you want to design a chip in square, then we put one piece. Width and height chip. If we change that, like 0.8 meters, width and height is coming to the rectangular format. And the strip width, and after that we can have see the arrange pin. We can go for the arrange pin. Yeah. So one window is open. So there in your RTL code, this is a pin to use as an input output. So this is the basically a pin. So if we want to arrange that key input, this is your IC. If you want to give to the input to the left side, so from that arrange of pin, you can make that. You make the input one that output pin to the right or VDD to ground, top and left. From that, but I don't do anything. I just leave this to the code flow. They arrange according to their requirement. So after that, we stop after placement. This is the placement is happening inside the IC. The placement is performed. So after that, we can also see the layout. For that, we click the edit layout. From that, we see the layouts of your counter. This is not so full view. This is the layout of your counter after the routing and using of the standard cell. So here use for the power and ground. This the bit you see there in brown color like this. This one. If you zoom it, you can see the name out there. This is ground. This is RST pin. This is the BDD. So this is a basically pin you use. This enable pins. This is count pin. The Ubuntu is already arranged there. Because we don't give the left, right, the we don't give the, that's what QPO arrange that they use it. So now we go for the second step, static timing analysis. Again, we click on the stop, the flow after the static timing, run that. You can see that there is okay, this timing is performed correctly. Then we go for the second route, the design. So we again perform the routing. We give the okay result means our routing is performed correctly. So after the routing, we can also see the layout, slightly different, looking different. Now this red line is showing that means this pins now connected to the other standard cell after the routing. Previous routing there is no this routing layer is not there, so you can see the difference. As the layout the routing is perfect correctly. Now this pin like this reset count, this is route to the all the standard cell, this BD and this reset pin, this is routed to the all the standard cell. Now perform the post-route STA analysis. Okay. I don't click on that, so that's why they run the other things. So after that, we see the GDS file. Now edit layout. This is the complete GDS file of our counter. After the placement, code planning, clock tree synthesis, after each thing, our GDS file or counter I see is looking like that. This is the complete GDS file. You can go send this to the fabrication and make the chip of zero counter. In this way, आपको दिख रहा होगा ना this packaging. This initially this is packaging. After that this yellow lines, yellow pins is there. This pin basically used so we can solder to the PCB after that getting the actions. So this is the RTL to GDS flow using one Q probe. From that we can get the GDS file and any regular code. So basically this is done, and this tool basically called a magic layout editor. This is a magic tool in which we show the layout. So after the Q flow, basically there is no folder previously, but after the running the Q flow, they generate the 4 different folders like layout folder, log file, source file, and synthesis file. Synthesis file में देखो उसने counter.blip, counter.sgf फाइल बनाई है, counter.spf फाइल बनाई है यहाँ से, और counter power and counter.spice netlist बनाई है. तो आप जो ये counter को spice simulator like ngSpice से आप test कर सकते हो. ये लॉग फाइल बनाई है, इसमें डिफरेंट जो स्टेप अपन ने किए हैं जैसे कि पोस्ट एसटीए एनालिसिस आप सी कर सकते हो, एसटीए लॉग को देख सकते हो. इसमें देखो इसने सारी पाथ का एनालिसिस किए हैं और उसके बाद इसने एक फ्रीक्वेंसी डिफाइन की है. दिस फ्रीक्वेंसी योर सर्किट इज वर्किंग परफेक्टली लाइक दिस. 895.816 मेगाहर्ट्ज और आप उधर से कैलकुलेट करो 8142 नैनो सेकंड को तो कितना फ्रीक्वेंसी आएगी कैलकुलेट करो. ये विदाउट पैरासिटिक और विदाउट राउटिंग है. और पोस्ट उसका भी एनालिसिस इसमें इस लॉग फाइल में दी होगी, उसमें भी आप देख सकते हो. ये सिंथेसिस लॉग फाइल देख सकते हो अपनी. ये सब क्यू फ्लो नहीं किया है, ये कितना काउंटर कितना क्या यूज कर रहा है. और ये लेआउट फाइल इसने यहाँ ये काउंटर की फाइनल जो GDS फाइल से यहाँ सेव की है that GDS file we will give to the fabrication and apart from this GDS file we also give to the lab file layout exchange format and dot DF file configuration file this all the file the key flow is generated automatically and stored into that layout folder so that हाँ हाँ जो फाइल फाउंड्री खुद मांगेगी जैसे मोस्टली काउंटर डॉट टीएस डॉट लैब फाइल टेक्नोलॉजी लैब फाइल टेक्नोलॉजी लाइब्रेरी फाइल दे ऑल फाइल वी गिविंग टू द फाउंड्री या फाउंड्री खुद ही अपनी जीडीएस और वो सब देती है यानी अपना टेक लाइब्रेरी लैब फाइल सारी देती है उसके बेसिस पे आप अपने डिजाइन का जीडीएस और लैब फाइल जनरेट करके देनी पड़ती है कोई क्वेश्चन किसी को This is the complete flow is the RTL to GDS. So now we see how to do the RTL to GDS using open access tool. So when you have any question you can ask.
सर इसमें वो तो केवल कैसे जनरेट होगी उसके बाद ट्रांजिस्टर लेवल से स्कीमेटिक की और सीधे कोड को करते हैं
ट्रांजिस्टर लेवल स्क्रिप्टिंग की जरूरत क्या है? लाइक की स्टैंडर्ड सेल का लेआउट अवेलेबल है हाँ तो लाइब्रेरी दे रही है फैब्रिकेशन में भी नीड लेआउट भी नोट नीड सिमेट्रिक हाँ लेआउट और एवरीथिंग इज इंक्लूडेड डॉट लैब फाइल लेआउट एक्सचेंज फॉर्मेट LEF फाइल दे टेक्नोलॉजी इज गिविंग
तो अलग से लाइब्रेरी के अलावा सर वो की लाइब्रेरी
नहीं लाइब्रेरी नहीं रहती लाइब्रेरी प्रोवाइड कराती है ठीक है एग्जांपल लाइब्रेरी का देखो मैं इस फॉर्मेट में आती है लाइब्रेरी जैसे कि ये रही ये पूरा फॉर्मेट होता है लाइब्रेरी का इसमें सीरियल रेसिपी जीडीएस लैब फाइल लाइब्रेरी फाइल इनका वेरिलॉग फाइल और देयर ईच स्टैंडर्ड फाइल ये एक लाइब्रेरी का मैं फॉर्मेट बता रहा हूं इस तरीके की लाइब्रेरी फाइल प्रोवाइड की जाती है फ्रॉम द फाउंडर में ये सारे फोल्डर्स रहते हैं इन्हीं का यूज करके आपको डिजाइन करना होता है तो जीडीएस फाइल जनरेट करके वापस उनको देना होता है फिर मेक द चिप
ये बाउंड्री कोड
हाँ ये फाउंड्री प्रोवाइड करेगा ये तो फ्री है तो फ्री वाली नहीं है फाउंड्री वाली अलग लेकिन फॉर्मेट आई जाता है सब एक ऑनलाइन किसी को डाउट हो तो पूछ सकता है टूल सीखने सबसे पहले तो आपको वन टू सॉल्व करना पड़ेगा लोग में ही वर्चुअल ऑफ काम सॉल्व करना वन टू थ्री अवेलेबल है तो उसमें सब फ्री ही यूज करना डाउट कोई ना हो push you down to you.